In this video, we're going to be talking about some of our prerequisite skills that we need to review before we jump into Chapter 2. Namely, we're going to be talking about factoring today, and we're also going to be talking about completing the square. All right, so I would strongly encourage you to try these on your own. So pause the video. You can see the first 8 questions I'm going to have you go through, and then jump back in and let's see how you did. All right. When I approach this factoring, we could either just factor out a 4, and that leaves me with 2 minus a. And that is fine, but really a better answer would have been to factor out a negative 4, because we like our variables to be first, but we don't like them to be negative. So if I factor out the negative as well, then I can switch this around and make it a minus 2. I strongly recommend, unless you are superhuman and never make errors, to go ahead and just double check by distributing back in and making sure all the signs work out, which they do. The next one, I hope very strongly that you look at this and recognize that this is one of our special case polynomials. This is our difference of two squares. We can see that we can take the square root of the first term, and we can take the square root of the last term. And so this answer is simply going to be 5x plus 10. And suddenly I'm realizing there's one more thing we're going to be able to do here, 5x minus 10. Now, as I was doing this, as I was writing the 5x, and then as I started writing the 10, little warning bells went off on my head, because I realized that I can still factor more out of the 5 and 10, and I can factor more out of the 5 and 10 here. So really, I should factor out 5 here and 5 there, making a grand total of 25 that I factored out, and leaving me with an x plus 2 and an x minus 2. So what that tells me, anytime you do this factoring, you realize that, oh, one of my, or both in this case, of my individual factors can factor further. What that tells us is we could have factored before we even started, factor out a constant, I should say. So I could have factored a 25 out of this one, and that would have made it 25 times x squared minus 4, which again would be factoring into what we have right here. But either way, the big takeaway is recognizing the difference of two squares. All right, and we're about to review the next bit here, but if you don't recognize it, really the only way to solve this is to visualize it as 25x squared plus 0x minus 100, and then go through the steps to try to factor a traditional trinomial. But clearly that's going to be not a lot of fun, and it would just be a lot easier if we learned to double check, or really we'll learn to spot those difference of two squares. Okay, part C, all the rules I have for factoring, the ones I use. Now let's pause, I guess, for a moment and say that I recognize that there are easily probably 5 or 6 different methods out there that people have probably been shown. The method I use, especially in a class like pre-calculus, is to use the traditional method of, hey, let's just look at it and figure it out. I don't use any boxes or any diagrams. No little. Some people use like a crisscross method of some kind, which honestly I've never even bothered to figure out how it works. For me, I just use common sense, in my opinion, which is I know how to multiply, and so I do that backwards. But none of it works with this negative in front. So I'm going to factor that negative 1 out first. And that gives me x squared minus x minus 12. So now for me, I'm going to just go ahead and assume it will factor beyond this and set up my 2 sets of parentheses. And then I know if I have x squared, I have to have an x and an x. And if I have a 12, then I know it has to be a factors of 12. So 1 times 12, 2 times 6, 3 times 4. And then I also take a look and I say, okay, this negative here, this tells me that these numbers, one of them has to be positive and one of them has to be negative. It doesn't matter which one, but one of them will have to be a negative, or I would never get a negative 12 here. But I also know that when I combine these positive and negative numbers together, I have to get an answer of negative 1. So I'm looking for those that basically will subtract to be 1, 4, and 3, but I want the result to be a negative 1. And so that means the negative will be on the 4 and the positive on the 3. So it's x plus 3, x minus 4. And then check to make sure there's not anything more you can factor, and then you're done. So then in part D, in a perfect world, you recognize, hey, this is a special case as well. But honestly, unless you're like knee deep in the middle of doing 100 of these problems in a row, you're likely not to even think of that. And you'll just kind of dive into it like we did on part C. But once we do, we say, okay, I'm going to assume it factors. I know it has to be an x and an x. Looking for numbers that multiply to be 25 and add to be 10. And I need it to be a negative 10. So that means I'm going to get negative 5 and negative 5. So I could rewrite the answer as x minus 5, the quantity squared. Now, I recognize this right away because I recognize this as what's known as a perfect trinomial square. And the reason I recognized it is because, or how I recognized it was, the 25 caught my attention. 25 is a perfect square. And so I can take the square of 25. It's 5. I can take the square root of x squared. It's x, much like I did here. But now I also am going to double check if I multiply these together and double it, do I get the middle term? And the answer is yes. So this is one of these special case perfect trinomial squares, and it'll always factor into either x plus or x minus the number squared. All right, and we will be revisiting that shortly. Part E. Now I have this extra complication with the 2 in front, and that's when some people start to think that this gets a lot harder. For me, I'm just going to do my same routine. I'm going to assume that it does factor. But now, instead of it just being an x times x in front, I know it has to be either a 1 times 2 or, well, I guess that's it in this case. So I know I'm going to have a 1x and a 2x in front of these two parentheses. Oh, and I don't have many choices for the 3. That has to be a 1 and a 3. So now all I'm doing is I'm looking to multiply the factors of 1 and 2 together and the factors 1 and 3 together so that the results will subtract or add to be a negative 1, depending on how you want to look at this. So what I do is I map through these. 1 times 1 is 1. 2 times 3 is 6. That does not subtract to be a 1. So that didn't work. So now I'm going to reverse it, and I'm going to try doing the 1 times the 3 and the 2 times the 1, and those do have a difference of negative 1. So now I know that it works, and I know the right combination. So I'm going to just throw in my x and 2x just in the front someplace. But now that I've placed those, I have to be very careful about where I put the others. We found that if I do the 2 times the 1, that's going to give me the numbers I need. So where am I multiplying the 2 by the 1? Where I put my 2? Right here, which obviously leaves my 3 to be here. Now finally, I want the result of this to be a negative 1. So this 3 that I'm building here has to be the negative, and the 2 has to be the positive. So my 3 is being built by multiplying these two together. And so that means I want the negative there and the positive there. Now that seemed like a lot because I'm talking through it, but honestly, I would have that factored in about 5 seconds once I've practiced and reviewed and I'm ready to go. Okay, let's take a look at part F. First, I'm always going to try to remember, but I forget sometimes, to factor something out of every term. And the 20 and the 15 had me excited for a minute about 5, but 37 I'm pretty sure is prime, which is a pretty good clue that I can't factor anything out. So I'm stuck. So once again, I'm just going to assume it factors. And then I'm going to find all the ways I can multiply to be 15. 1 times 15 and 3 times 5. Luckily, there's not that many. I'm going to find all the ways I can factor to be 20. And I'm always very methodical about this so I don't miss any. Oop, but I'm not paying attention. There's no 3. 4 times 5. All right. So now I'm looking to mix these factors together through multiplication in order to add to get a 37. So the process would look something like this. And I would usually maybe not start with the most extreme numbers, the ones, but just to illustrate for those of you who need to see it. I'm going to start and do a 1 times 1 and get 1, 15 times 20, which is very big, and then I'm going to add those together to get 37. I don't think so. So that didn't work. So now I'm going to switch it. Now I'm going to do 1 times 20, which is 20, and 15 times 1, which is 15. Those had to be 35. That was close, but we didn't get there. So all I know is the combination of 1 and 15 and 1 and 20 is not the answer. So now I'll try it with the 2 and the 10. 1 times 2 is 2. 15 times 10 is 150. Clearly, that's not going to add. So we can throw that out. Switch it. 15 times 2 is 30. 1 times 10 is 10. That's 40. That did not work either. I'll try it with the last one. 1 times 4 and 15 times 4. That's not going to work. 1 times 5 is 5. 15 times 4 is 60. That's not going to work. So what you've seen me do is I've tried the 1 and the 15 with every one of these sets of numbers it could go with, both as 1 and 20, and then flip it around as basically 20 and 1. And it didn't work in any way. So now I know this doesn't work. So now I'll try it with the 3 and 5, and I'm going to save a little time and maybe do those numbers more in the middle instead of the extremes. So I'm going to go 3 times 4 and get 12, 5 times 5 and get 25, and there's the answer right there. Those combine to be 37, and I want the answer to be a negative 37, and this is a plus sign. So that means both of these are going to be negatives. All right, so I'm going to put in my 3x and my 5x, and then I've got to place the others carefully. So I decided 3 times 4 was the answer, so I got to do 3 times 4, because that's what gets multiplied when I do FOIL, and so then the 5 would have to go here. On one this complicated, probably a really good idea, unless you're really confident, to check your work. 3x times 5x, 15x squared. We knew that was going to happen. Negative 5 and negative 4 is positive 20, so that's good. 3 and 4 makes negative 12. Negative 25 is negative 37. It's factored. Clearly more options here, but again, I want to stress, if I was doing this not for show, I probably would have started with the 3 and the 5 and the 4 and the 5, and I'd have found my answer immediately. Okay, so that is the factoring for that one. All right. In most cases, we won't really be able to factor things that are cubics. So once you see a cubic, you're kind of like, oops, I guess I can't do anything. But there are 2 cases where you can. One of those cases is this one. And I hope that you look at this and notice right away that there's an x in every term. So I can just factor the x out. And now I'm left with this, which I will try to factor further. And I get x and x, and I'm looking for fat numbers that multiply to be 6 and subtract to be 1. So that's going to be 3 and 2. I need it to be a negative 1, so negative 3 and a plus 2. Don't forget the x that you factored out originally, and there we go. All right, and the last one is, at first glance, obviously we can't do what we did here because I don't have an x in this last term. And there's nothing I can factor out of everything because the 2 and 5 don't work together. So I'm either kind of dead in the water, have to use more complicated methods like we'll talk about at the end of the chapter, or what I can try is something called factor by grouping. And depending on who taught you, you may or may not have had a lot of experience with this. I did not stress it all that much, but we did do it in my classes in Algebra 2. So I'm looking at this, and what I'm going to try to do is I'm going to just sort of artificially throw parentheses around each of the first 2 and the second set of 2 terms. And the goal here is that now we're going to factor out of each of those smaller pieces and hope to be left with something that is identical. And if we're not, then it won't work. So let's see what we're talking about here. Looking at this first one, I can factor a 2 out and an x squared. So I'm going to factor out 2x squared. And then I'm left with, and just to highlight it, I'm going to put it in red. I'm left with x plus 2. And then I go to the second one, and I'm going to factor out a 5. And I'm left with another x plus 2. What this means is now, if I look at this as one term and this is one term, and I look at the factors, I can see that they have a factor in common. They have the bigger factor, x plus 2, in common. So what that means is I can factor the x plus 2 out of each term, just like I did, for example, on part G with the x, right? I said, hey, there's an x in each term. I can factor it out, and it comes to the front. Well, here it is. It came to the front. It's an x plus 2 and an x plus 2. And then what am I left with? I'm left with a 2x squared and a plus 5. Now I'll check each of these individual factors to see if they factor further, and they do not. Anytime there's two terms and it's not a difference of two squares and there's nothing in common, then I know that it's not going to factor further into, at least into integers or even into rational numbers. Okay, I think that about does it for those. So we need to remember how to factor. We're going to practice that today. And then the second major topic we're going to review is a little thing called completing the square. All right, so completing the square comes from, where should I scribble this at? I will scribble it, I guess, right up here. Completing the square comes from what happens when we do, let's say, x plus 3 times x plus 3, which of course we know is x plus 3, the quantity squared. Well, we know a shortcut for that, but just to kind of see it all in action, let's do it the short way, or the long way, excuse me. X times x, FOIL it out, I get x squared. X times 3, I get plus 3x. And then I do 3 times x, and I get another 3x, and 3 times 3 is 9. Since I have a 3x and a 3x, they got doubled, so I have x squared plus 6x plus 9. Our shortcut, had we just gone ahead and used our shortcut, is, and again, no term by term. We can't just say it's x squared plus 9, because it isn't. But we can cheat and say, hey, I know a shortcut. Square the first term. Square the last term like you wanted to anyway. Oops, that was weird. But then there's a middle term, and the middle term is we multiply them together, and then we double it. Why do we double it? Because it happens right here. We get a 3x, and we get a 3x. And so we do x times 3 and get 3x, and then we multiply it by 2, and I get 6x. Okay, so wanted to go over that because if we look at this in reverse and I tell you to factor this, then it's obviously going to go back to this or this. But how do we recognize it, or how do we do it? Well, what I do is I'm going to just do a check. I'm going to take half of 6, which is 3, and I'm going to do 3 squared, which is 9. So if all that works out and is true, then I have a perfect trinomial square, and I know the answer is going to be this half number we did right there. Then the answer is just going to be the x plus 3, the quantity squared. Take half of 6 is 3, square it. Is it 9? If it is, then it'll factor into this. Okay, so we want to make use of that fact, and we want to do exactly what this says. We want to complete the square, meaning we want to take something that maybe isn't a perfect square, and we want to make it a perfect square. So the first thing I want you to notice is that if I asked you a question on part A and I said, hey, is this one of those things that will factor nice and easy into a binomial squared? In other words, is this a perfect square? So the check we could do is we would take the half of -8, which is -4, and I would square it, and I get positive 16. So I look here and I say, is this plus 16? Obviously, the answer is no, it's not. Well, what that means is this is not then a perfect square, and it will not factor into something like this. But we want it to, because what I want to do is what I'm trying to do is create vertex form. And if you remember our shortcut for vertex form, it would look something like this. Y equals A times X minus H, the quantity squared, plus K. And I want you to see what's sitting right here in the middle of vertex form is this binomial that is being squared. That's what we got from here, right? It's a binomial squared, and we got it from our perfect trinomial square. So every vertex form has a perfect trinomial square hidden inside of it. We just have to find it. So here's what we do. We look at this problem, we say, is 19 the right number? And it rarely is. In fact, I usually don't even ask. I just assume it's the wrong number. This is not the number I need to make a perfect trinomial square. So what I'm going to do, when I write this down, I write it down and I scoot that number, the plus 19, over to make room for at least one number to one term to be added in the middle. And now all I do is instead of ask, is it the right number, I make it the right number. So we just go through our thing. What is the right number we need it to be? So I'm going to come here and take half of -8, which is -4. And I want you to actually write that down because we're going to need it in just a minute. And then we're going to square that number, which gives me a positive 16. That's the number I needed. Okay, so I'm ignoring this 19. I scooted it away, and I put a 16 here. With this 16 being here, now if I focus, I'm going to just ignore that 19 for a minute. If I just sort of look at the problem right here, that is now a perfect trinomial square that I created. I completed the square. I put the right number we wanted. And I can now check it. If I factor this, the square root of x squared is x. The square root of 16 is 4. That's why I had you write it down, because we were going to need it. And then if I do 4 times x and double it, yep, I get the 8x. So I completed the square. So this part of it factors into this. Now, if you're paying attention, you're hopefully shouting at your screen, although you probably know how to do this, so you know where this is going. But I clearly can't do what I just did. I can't just put a 16 where I don't have it. I'm not allowed to just make stuff up. That doesn't work. So I have to balance out my equation. So there's two ways I could balance this equation. One way would be like we've always done in math, is if I add a 16 to the right side, then I really should come over here and add a 16 over here. But there is another way, and that other way to keep things balanced is I added a 16, so what else could cancel that out and make it balanced? I could turn right back around and subtract a 16. So by adding 16 and subtracting 16, I have changed nothing. But by grouping it the way I have and taking that 16 I added and turning that into x minus 4 squared, and then simplifying this, I get plus 19 minus 16, which is plus 3. So if I simplify that to add 3, then I am now in vertex form. All right, and to verify that, are these exactly the same? Is this really this? Let's just see what happens. I'm going to take my x minus 4 and square it. So I get x squared minus 8x plus 16. And I've got my plus 3 sitting here. And you can see that it is exactly what we started with. So these two statements are equivalent. And now one's in vertex form and one isn't. So I can graph this nice and easy now. 1, 2, 3, 4. 1, 2, 3. And no vertical scale change. Over 1 up 1, over 1 up 1, 2, 3. 1, 3, parabola, graphed. All right, that was quick. Obviously, I'm just reviewing this versus teaching it. So hopefully you're like, oh yeah, I remember. And so let's go ahead and try another one pretty much just like the last one. Is that true? let's see. I guess I went ahead and made this one a little bit harder. Let me see what's next. Okay, let's do part C first, and then we'll jump up and do part B. All right, so pause this video and go ahead and try it yourself. All right, so the key here is we're just assuming the 6 is the wrong number, so I'm just going to get the heck out of here. That was probably too far away, but who cares? I'm now just going to ask myself what's half of -4? -2. And I'm going to square it and add that right here. And I need to see that you've added it in there. And then I'm going to turn around. Since I gave myself so much room, I'll just turn around and subtract 4 right there. So now I'm going to group this stuff together. And I get y equals x minus that 2 I saved for later squared. And then -4 minus 6 is -10. So now I see I'm in vertex form. I'm going to go over to 2 and down 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Up 1, up 3 more for a total of 4. 1, 2, 3. Up 1, up 3 more for a total of 4. And I'm graphed nice and simple. All right. We will practice those today. Let's go back up and look at part B. All right, part B is slightly harder. And the reason is because we have a 2 on that leading coefficient. So there are a couple of ways we could deal with this, but the easiest way, or at least the way we're going to be doing it in class, is we're going to factor that 2, but we're only going to factor the 2 out of the first 2 terms. So here's what this is going to look like. Y equals, I'm going to factor the 2 out of the x squared, and then this would be plus 6x. I'm going to scoot over a little bit, leave myself room for one number, or one term, close off that parentheses, and I'm going to put the plus 11 out here by itself. Again, I haven't not changed the problem. 2x squared distribute, 12x distributed, plus 11, same problem. So now I'm going to complete the square by taking half of 6, which is 3, square it, and add it right here. And then we're going to make our first mistake. So here is a common error alert. I'm not subtracting 9. Add 9, subtract 9 seems good. The problem is I did not really add a 9, right? I added, because where's the 9? It's in parentheses, so when I distribute the 2 through, I see I've actually added 18. So that means I need to subtract 18. So there's 2 ways you could kind of handle this. We could just try to remember, which is what I do, or you could say I added 9 times 2, right? So now I need to subtract a 9 times 2. Either way, you just have to remember, I guess. There's really nothing. Again, sometimes I think some of us look at math and we think it's a little bit magical. Oh, look, we're just throwing a 9 here and we've got some notation and who cares? But we're literally putting a 9 in here, which means we're doing a 9 times a 2. So do what it says. This is adding 18, so I need to subtract an 18. Honestly, it's just something you're going to have to pay attention to, maybe get wrong a couple of times before you remember. So why did I do all of this? Well, the parentheses is now a perfect trinomial square, so it factors into this. I've still got my 2. Now I've got 11 minus 18, which is -7. And there we go. So now I see I have a vertical scale change of 2. So I'm going to shift over 1, 2, 3, down 7. 1, 2, 3, 4, 5, 6, 7. I have my vertex at -3, -7. And now I'm vertical stretch of 2. So over 1, up 2 this time. Over 1, up normally 3, so now it'll be up 6. 1, 2, 3, 4, 5, 6. Map it over the other side. The next one would be over up 1, up 3, up 5, but it'd be actually up 10 for the total because of the vertical scale change. Okay. And I think I've got one more. Part D. All right. Now, we don't like fractions, but the more we just deal with them, the less they'll be scary. So just like before with that 2 sitting there, I don't want it, so I got to factor it out. So I'm going to factor out a half, and I've got x squared. And then what did I factor out? How do I get this next number? Well, when we're factoring out a half, what we're really doing is we're then dividing the things we're factoring by, the 1/2 and the 3x, we're dividing by a half. Or dividing by a half is multiplying by 2. So this is actually going to be plus 6x. Give myself some room, close it off, minus 1. Definitely when I'm dealing with fractions or if I'm factoring out negatives, I double check. Half times x squared, half times 6 is 3. I'm always just sort of curious if I get that one right, so I always want to make sure. And now I do my thing. Positive 3 squared is a plus 9, subtracting 9/2, or 4.5, right? And so now this factors, because I set it up to do so. I got my 1/2, and now I've got 4.5 and 1, so I've got negative 5.5. Might as well go ahead and turn it into a fraction since I need to graph this. 1, 2, 3. 1, 2, 3, 4, 5.5. All right, up 1. I'm sorry, over 1, up a half. Over 1, up 3/2. Over 1, up 5/2. 1, 2, 3, 4. Would be at negative 1 there. And there we go. All right, I hope this served as a good reminder of completing the square. If you have any questions while you're doing your work, just plan to come spend some time with me. All right, see you on the next one.